Oh, somebody stole
Don't tell me, don't tell me, no spoilers. Right, yeah, we're here today to talk about web performance. So, imagine you've just written an absolutely amazing website. It's beautiful. All of your colleagues agree, everyone's seen it, you've been through extensive user testing, and everyone thinks it's the most amazing website that they've ever seen in their lives. And then you put it into production, and you load it for the first time. And you look at this screen, and you keep looking at it, and you think, what the hell is going on? This worked fine in dev. And it takes 10 seconds or so to load. And you think, okay, maybe it's like some sort of ops thing, as an infrastructure thing. You know, the web server needs to do some caching, some optimizing, I'll reload it again. It should be faster the second time. And you load it again, and the second time it takes 9 seconds. And you think, Jesus, what's actually happening here? And so you pull out a mobile device and try and load it up, and it takes like 20 seconds on a 4G connection. And you're like, something has gone mysteriously wrong here. Something has gone completely wrong. And that is a situation that I found myself in recently, because I literally thought that all computers and all internet connections were just like infallible. Anything could just load my website. But it turns out that's not the case. Performance is like a really important consideration that you need to continually make choices about when you're developing your project. So I think it's a good idea to address these issues, and let's talk about web performance. So today I'm going to talk about a little bit about how a rendering engine builds your web page, because that's a really important consideration when you're thinking about performance. I'm going to give you 7 tips to improve your performance with CSS. I wanted to give you more, but there's nowhere to fit it into 15 minutes. And then I'm going to talk a little bit about how to convince a business that this is a really good idea. So this is how a web browser engine will build your web page. It will take your HTML, and from that it will build a DOM tree. It will also take your CSS that you've given it, and with that it will build a CSS OM. It then combines the DOM and the CSS OM into a render tree. It will then perform a procedure known as the layout, which will turn it into a box model. And the box model is basically how all of the squares, all of the rectangles that make up your web page, kind of where they'll sit, how wide they are, and what position they'll take within the screen. And then it will go through the paint procedure, and that will actually put the pixels from your web page onto the screen. So that's more or less in a really simple way how a browser builds a web page, and that's called the critical rendering. So on the critical rendering path, there's a number of operations that will block things from happening. The first thing is fetching CSS. Basically, while your web page is fetching CSS, nothing will happen, because the browser knows that the CSS is going to affect how things are painted on the screen, and so it will just sit there and wait for the CSS to download before continuing down the layer with the render tree, building the render tree. Also, fetching JavaScript. It's not going to build your render tree until all the JavaScript has been downloaded, because there's a chance that the JavaScript will affect how your render tree is built. And so it will just sit there waiting for all the JavaScript to download before building the render tree. And this sort of thing slows down your website significantly. There's ways around the JavaScript blocking your website, but we won't go into those today. We'll just focus on the CSS for now. So tip 1, it's important to avoid serving unnecessary CSS. I'm sure you've all probably seen this sort of syntax, which means that you can take all of your CSS and you split it into content that's aimed at different browsers. So certain browsers are not going to support certain CSS rules, like transitions or any CSS3 stuff. IE9 probably won't support that, or anything below. So you can just tell IE9 to only load a subset of your styles. and that means that people who use that browser won't have to download everything. There's also this really cool utility called CSS, and what that does is it fires up your website in a headless browser. It determines which styles you're not using in your style sheets, and it will just knock those out for you, so that you can commit like a really sort of minimized version of your CSS, and it will just trash all of the stuff that you're not using. Tip 2, media queries. So I said earlier that CSS was blocking. No, the render tree doesn't get built until all of the CSS has been downloaded. Now that's not strictly true, because you can use a media query within the link element of your CSS, and that means that this style sheet will only get downloaded, and it will only be a blocking operation if the user has their device in portrait orientation. If they don't have the device in portrait orientation when they first load the page, then it won't be downloaded as a blocking operation. It'll be downloaded later, so that it's not going to block the initial render. And likewise, if someone's using quite a small screen and the browser rendering engine hits this line, it won't download this large screen style sheet until later, basically, so it doesn't block the initial render. So that's a really cool thing you can use, and that way you can separate all of your style sheets into things that only matter for certain users. Tip 3, prioritize visible content. Always focus on what's above the fold. It's kind of a bit of a magazine-y term, but above the fold means what the user can see when the page first loads. So anything that you can't see in that initial sort of viewport is known as below the fold. And the idea here is to not care so much about CSS that only affects things that are below the fold. And so that way you can either inline all of the CSS that affects things above the fold, or you can use JavaScript to download below the fold stuff later, so that it's not a blocking operation. There's a cool link there that you can check out and read all about that if you need more info. Tip 4, minify. Always minify your CSS code. I'm sure everyone does anyway, but it's worth repeating. And you can do the same with JavaScript. You can set up a goal, like Luke showed earlier, to minify all your CSS automatically, so you don't have to worry about it. And that way you're serving less codes to users. Performance CSS, right? Pop quiz. Who can name the most performant selector? Anyone? 4. Number 4. That's right! Oh, where's my presents? Where's my presents?
Oh man!
Dude. Who can name the second most performant selector?
3.
2.
2! Oh! Well done, Carlos! Yeah, I'll have a present.
Sure, I cannot see the solution.
Cool, yeah.
I cannot see the solution. No.
What's the third most performant? Anyone?
I was thinking about this today, wondering what was.
Have a guess. Go on, Luke.
Yes.
I would think 3, just because it's not. Because A isn't a class or an ID.
Cool. It turns out this one is. But you're going to have some sweets anyway, because hey, yay, you came, and yeah, why not? Richard, you can have some sweets as well.
Thank you very much.
So yeah, it turns out that the most specific selectors are more efficient. So obviously number 4 here is the most specific. So that's the most efficient. But the second rule, and this is probably the most confusing one, is that CSS reads from right to left. So if you have a less specific selector at the end of your CSS rule, then your CSS will be less efficient. So it's good to keep your more specific selectors at the right, because if you have, like, say number 3, you have the A tag at the end. Basically, the browser will go through every single A tag on your page, and then it will look at the parents of that A tag to see if it matches the next part of the rule. So
I never would have thought that.
Yeah, I thought it was the other way.
Yeah, because I would have thought that number 1 would have been loaded, or would be more performant than number 2, because it starts with a more specific selector. It reads right to left.
Yeah. Totally, it's very counterintuitive. Obviously, this example is very contrived. There's probably no reason for number 2 to have this nav link over here. Well, you wouldn't have it in a class, for instance. It's just nonsense.
So is it almost it's the opposite of how specific they are, in a way? Is it?
No, you still want specific things. You don't want to see many tag selectors in your CSS at all, because it's gonna hit the performance, and it's probably gonna be overwritten by something else anyway. Cool. So number 6, descendant selectors. Oh my god. Yeah. So I know SCSS kind of encourages this, but you tend to end up with like these descendant selectors, and that means it will look for any A tag. It will check to see if an A tag is sitting in a H1 tag, and if it is, then it will check to see if it's in a header tag. This is really inefficient, and it's really slow. So slightly better is to use the child selector, and that means that it will only detect the immediate child or the immediate parent of the selector, and it won't look through all of the parents. But it's slightly better. But really, the best thing to do is to either use inheritance. So down here we're setting the font size on the header element. So the font size down here is less relevant, really, because this font size will be applied to everything in the header, including that A tag. Or to use class as your selection, and just try and keep this like 1 or at most 2 deep. If you start building like really long chains of selectors, then it just slows everything down. And final tip number 7, fonts. Oh, fonts! Fonts are horrible. I've realised this now. Fonts. If your external font hasn't downloaded before the first paint, it will block the paint. So your page will just sit there waiting for a font to download with a big white gap where the text should be, and then it will wait for the font to appear. And then only when the font has been downloaded will it paint your text. And it's just nonsense. The user doesn't care if you're using like a really sort of fancy web font. They want to read what's on your website, you know. So we've got to find ways around it. Unfortunately, like all the browsers have different strategies for displaying fonts. So in Safari, fonts are always blocking. So Safari will always wait for the font to download before it displays any text. With Chrome and Firefox, it has kind of a sensible fallback. So after 3 seconds, if your font still hasn't downloaded, then it will just fall back and use a different font. But with IE, it always uses a fallback font. No matter, even if you are using your fancy font, it'll always use a fallback font, so it'll display your text straight away, and then when your font gets downloaded, it will re-render everything to display it in the new font. I don't know which of those is a good thing.
That's the most sensible one then, really.
I don't know, it's a bit jarring to see like everything re-render after a while.
Yeah.
What the Guardian does, the Guardian are really good for their performance, they're really renowned for it. And so what they try and do is they will always use a fallback font the first time you access the website, and then they'll download the font in a non-blocking way, and they'll store it in the local storage of your browser. So they kind of cache it, so that next time you visit the page, it can automatically display everything in their intended font. It's kind of a bit over-engineered, but they kind of love it. Sort of stuff. So I don't know, how am I doing for time? Am I overrunning a little bit?
14 minutes now.
Oh, I thought, okay, fair enough. I'll show you something else later. So the last thing, convincing the business. So we really need to convince the business to let us do this sort of stuff. If we just say, oh yeah, we want to refactor everything, they're going to just say, screw you guys, I want more features. So it's important to give them good KPIs, good key performance indicators to convince them that what you're suggesting is a really good idea. So if you look at things like the bounce rate, the amount of users you lose between pages, or the number of click-throughs, or the session length, or the time to first click, so that's the time it takes for the user to actually make a first click on the page, or the time to first scroll, sometimes that's kind of important. You want to see how long it takes before the user scrolls. You can use these sorts of metrics if you can, if you're sensible, in order to convince the business that reducing the amount of time that a user sat there waiting for something to appear is a really good idea and really needs consideration. Also, compare with competitors. There's nothing like saying to someone in marketing that a rival website is faster at downloading than we are. It kind of kicks their ass, and they sort of say, oh my god, well then we need to address this, and they start getting a little bit crazy. And that's the most important thing, I think, is make a real difference. If you spend two months or something doing a refactor of your website and it doesn't change anything, then you're going to lose the trust of your business. So you've got to use like all the metrics and all the tools at your disposal, any dev tools, any sort of like audits and things, in order to make sure that what you're doing is actually going to make a difference. And it's not going to be just like a change that actually does not improve the performance of your website. Otherwise they'll never let you do it again. And then you'll be screwed. So yeah, there's a bunch of links there. I'll send out a link to these slides anyway. Yeah, Google's dev tools are really good. Paul Irish is a really cool guy who does a lot of performance analysis, and this David Mosher guy is really cool for explaining like how a browser renders things. So that's about it for now, and yeah, you can talk to us after if you have any questions.